Hi, welcome back. In this video, we are going to discuss about IGCSE O-Level challenging and critical thinking questions. Here I have some collections from Singapore syllabus and then old question papers. So it has some challenging and critical thinking questions. So I thought this will be helpful for you during this period that you are having a good opportunity to prepare more and to get a star or brilliancy award. Okay, let's start. Here is the first question. You see here there are three blocks PQR, identical blocks, resting on a smooth surface as shown below. A force of 30 Newton is applied at one end as shown here. Here it is 30 Newton is applied. What are the tensions T1 and T2? In between these blocks, PQ and QR, there are tension forces. When the 30 Newton force is acting on this side, this string and this string will experience a tension force. So this force will not be 30. Here is 30, so this will not be 30. This is what we are going to discuss about. They are asking what is the value of T1 and T2. So let's give some value here, so it will be more easier for us for our better understanding. So equal identical blocks, so I give value 10 kilograms for all. Now let's explore. Here we are applying the total force for these three blocks, 30 Newton. So that is the net force. We have the total force 30 Newton, and here the mass of the three blocks, total blocks 30 kilogram, which means the acceleration. Now I want to find, so force over mass. So the total force 30, total mass 30, so 1 meter per second square is the acceleration for all these three blocks. So it is going to accelerate with the same value, 1 meter per second square. So this is our first clue to find the tension for these two. Now let's find the tension for this string. For this string there are two objects, P and Q, two blocks are there. So I'm going to find the tension. Tension is the force, it is balanced by the force, the net force, that is mass multiplied by acceleration. Mass of tension to this here. So how many mass here? Two blocks. So 20 kilogram, and then acceleration is here 1. The acceleration will not be changed. So 20 Newton is the tension force. Now we can find for T1 here. So this tension and then force is balanced. So the force will be equal to mass into acceleration. So mass here, there is only one block. So 10 kilogram, acceleration is 1. So 10 Newton. So T1 10 Newton and T2 20 Newton. Here it will be experiencing 20, and here it will experience 10 Newton. So the answer is here T1 10 Newton, T2 20 Newton. Okay, and we can discuss the second question, the next question, number 2. So better you can pause this question and then you can try to do on your own, then later you can check. So you can explore on yourself, and then it will be good. If you have any doubt, you can check it later. But first, better if you can try. You can pause this video and you can try. Now you see, student, here a bottle is filled with water and has a mass of 45 gram. So we can draw a diagram. Here is a diagram, that is a bottle. Sorry for the diagram. And here is a bottle of water, 45 gram. When it is filled with an unknown liquid X, its mass is 360 gram. There is another liquid, but we are pouring, sorry. We are pouring this liquid, unknown liquid here, and which has a 360 gram, and here it is water, and this is, we don't know, some liquid, but the bottle is the same, the volume of bottle is the same bottle we are using. If the mass of the empty bottle is 20 gram, which means we have to subtract 20 gram from both. So here it will be 25 gram, that is the mass of water alone. Here it is 340 gram, the mass of unknown liquid. This is the mass of water, this is the mass of unknown liquid. So what is the question? What is the density of a liquid X, unknown liquid X we are going to find? So here the formula for density is mass of the liquid, unknown liquid, divided by the volume of the unknown liquid. So we don't know the volume of unknown liquid. So we are trying to find the volume first. Volume of the bottle is equal to mass over density. So the volume of the water will be equal to volume of the bottle, right? So the mass of water is here 25 gram, divided by the density of water is given here 1 gram. So it is 25 centimeter cube, because all the values are here in CGS units, centimeter, gram and seconds, CGS, centimeter cube, right? Now the same volume we are using for the another liquid, and the mass of the liquid is given here. We already found it, 340 gram, and then volume is same, 25. So the answer is 13.6 gram per centimeter cube. So here is the answer. Next question. Question number 3. You can pause this video and then you can do it on your own. Read the question. Here, a movable slider divides a sealed cylinder. The cylinders are sealed. The cylinder is sealed here from both ends with gas into two equal halves as shown in the diagram. So here is the slider which divides the cylinder into equal half. It filled with gas as pressure 10 pascal each side of the slider. So it has a 10 pascal here, the pressure 10 pascal. Now what happened? Gas is then pumped into the left half of the cylinder while holding the slider fixed. You fix the slider here, hold the slider fixed, and you pump air into it. So when you pump extra air, more molecules will be here inside this left side. Here is right side. So more molecules causes more pressure because more collision will be there. Now before it was 10 pascal, now it is changed to 30 pascal after you introduce gas into it. So it becomes 30 pascal now. So how much is increased? The difference of pascal is 20 pascal increased. Here is still 10 pascal. So here more pascal. So here the force will be more hitting on the slider. So the slider is going to move to the right side. The slider is then released. Where is the new equilibrium position of the slider? So it has to take some distance away from here, away from this side. It is going to the right, and it will stop somewhere when the pressure is equilibrium, gets equal in both sides. That is called equilibrium. So we have to find the new position of the slider, this side, which position. And here you can see temperature remains constant, which means temperature remains constant, which says the Boyle's law. Boyle's law assumption is temperature is constant, mass of gas is constant. So here the mass of gas is not constant right now, but this is the previous case before, when it is equal in pressure. Here is 10 pascal. The volume is area multiplied by the length. Area of cross section, both sides are equal. So no need to mention about the area. The length is here 20, here is 20. 20 is the length, area is A. So you can write 20 times area. Here the pascal pressure is 10 pascal and 20 times area. So area is cancelled. So this is the constant value both sides, right? Now how much is introduced? That some gas is introduced, so it becomes 30 pascal. So excess of pressure is 20 pascal. Now we can find how much volume it is going to take. This value is 10 times 20 is 200. Now we have to find the excess pressure, how much volume it is needed. So we are going to find the volume. So you can divide this 20 in the other side, you will get 10. 10. That means it will take 10 centimeter length with the same area of cross section. So it has to move 10 centimeter to the right. When it moves 10 centimeter, 20 plus 10 will be 30 centimeter. So it will be, the new portion will be here. 30 centimeter is the answer. So next question. Yeah. Question number 4. Here this one you have. It's not, we are not going to get this answer within 1 or 2 steps. There are 3 steps we have, and it carries only 1 mark. Okay, let's explore the question. 0.1 kilogram of ice at 0 degrees Celsius is dropped into 1 kilogram of water at 18 degrees Celsius. So we can draw a diagram. So here is a water, 1 kilogram of water. Initial temperature is 18 degrees Celsius. And we drop some ice cubes here, and which has 0.1 kilogram of mass. And the temperature is at 0 degrees Celsius. Now the highest heat energy is in the water. Here is the lowest heat energy. Heat energy will transfer from hot to cold. So the ice cube will receive heat energy. Water releases heat energy. So first we have to find out the total energy the water has. So we have the formula, that is E is equal to mc delta T. So the mass of water 1, specific heat capacity 4200 for water, and the temperature now it has 18 degrees Celsius. The total energy will be 75,600 joules. This is the total energy in this system. Now what happens? Some of the energy is received by the ice cube and it melts. So how are we going to find the how much energy the ice cube needed to melt? We have the formula, that is E is equal to ml. This is the melting formula, state changing formula. Here the mass of ice is 0.1. The specific capacity is given 3,036,000. If you multiply, you will get 33,000 joules. Now it absorbs 33,000. So automatically the energy from the water is reduced. How much? It is reduced by 33,600. So the remaining energy is still there, 42,000 joules of energy still the water consists. Now what happens after the ice cube receives this much amount of heat energy from water? Now ice cube melts. Now the system contains water. Ice turned to water, and here is a water. So the total mass of system is now 1.1 kilogram, right? 1 kilogram water and zero point 0.1 kilogram ice melts to water. So it becomes 1.1 kilogram is the total mass in this system now. Now again we are going to find out the energy. So how are we going to find? E is equal to mc delta theta. So we are going to find the final temperature for this system now, because it is water. So delta theta is equal to E divided by mc. So the mass remaining energy water consists 42,000, and here the mass of system is now 1.1. specific heat capacity is 4200. So if you simplify, you will get 9.090909 degrees Celsius. So here the closer value is 9 degrees Celsius. So this is how we are finding the answer. So you have to think in various directions to get a concept, to get an answer. Okay, let's discuss the next question. Here is the sixth question, and it is a interesting question. You can see, if you want, you can pause the video and then try to solve the question by yourself. Two plane mirrors intersect at right angles. Here is one and here is another one. It intersect at right angle, that is 90. A laser beam strikes the first of them at point 11.5 centimeter. Here is a laser beam and it hits at 11.5 from the intersection point 11.5. This is the length. And here, for what angle of incidence at the first mirror will this ray strike the midpoint of the second mirror? This is the second. Here is the first mirror and here is the second mirror. The total length is 28. So here the midpoint is 14. So here will be 14 centimeter. Here will be 14 centimeter. Here is the midpoint. So they say the laser beam will reflect and then will strikes at the midpoint of the second mirror here, reflected. And we draw the normal here. Draw the normal. They ask you to find the angle of incidence of the first mirror. This angle we have to find. What is the angle? So how are we going to solve this question? So here if you see, we know the sides. Here this side and here this side, and this is 90 degrees. So it is going, we are going to use the trigonometry or Pythagoras theorem to get the answer. So it will be the trigonometry. If you want to find this angle theta, it will be easier. So how are we going to find this angle theta? Use tan theta, sin theta, cos theta, any value. So tan theta will be opposite side by adjacent side. So here opposite side is 14, adjacent side is 11.5, that is tan theta. So theta is equal to tan inverse 14 over 11.5. So the answer is 50.59 degree. So here is 50.59 at this point. Now you know the total angle here, when you draw the normal, this complete angle is 90. So this angle is 50.59. The total angle is 90. So we subtract by 90 minus 50.59. You will get 39.4 degree. So now we found this angle of reflection, that is 39.4. And we know law of reflection, angle of incidence equal to angle of reflection. Angle of reflection is 39.4 degree. So the angle of incidence must be 39.4 degree. So the answer is here, 39.4 degree. So it is interesting, right? Next video we can discuss some more questions. So thank you very much for watching my video. Bye.